Assalamu alaikum. In this series, Mr. Omar will guide you through some practice problems to cover all items included in the coverage issued by Emirates Schools Establishment, E.S.E. This is part 6. Have a fruitful time.
Assalamu alaikum wa rahmatullah. Welcome back. We are now at part 6. We will discuss some special circuits, including Kirchhoff laws and Wheatstone bridge. This is question number 3 and the goal number 18. For the given Wheatstone bridge circuit, if R1 equals 1, R1, here is R1, it is 1, and R2, here it is R2, 2 ohms, this is 1 ohms, and R3 6 ohms, here we have 6 ohms, and Rx 3 ohms. Now before proceeding with this circuit or with the question, let us examine if the bridge is balanced or what. Take the first leg of the bridge, here this side, R2 over Rx. It is 2 over 3. On the other side, we have R1 over R3, the same order. It is 1 over 6. They are not equal each other, so the bridge is not balanced. So no equilibrium here. And the current will flow through the resistor R0. Now let's go back to the question and see what is the problem. Find the resistance of a resistor to be connected to R3. We need to make some changing here so as to achieve the balance condition. Then how much is the current that passes through the cell at the equilibrium? Let us redraw the circuit with R3 unknown. Here is our circuit. Now R1 is 1, R2 2, Rx 3. This is 1, this is 2, and this is 1 is 3 ohms. Now R3 it is 6 ohms. Now we want to assume that this circuit is unknown. This R4. Now for equilibrium or for balanced bridge, R2 over Rx should be equals, this side should be equal to the ratio of the other side, R1 over R4. Now R2 it is 2, Rx 3, R1 1, R4 it is unknown. If you do the calculation, you will find R4 equals 3 over 2, which is 1.5 ohms. Now compare it with R3. R4 it is 1.5 ohm. It is less than R3, which is equal to 6 ohms. So if you want to reduce the resistance between these 2 points, at this point A, B, C, D, between CD we have R3 with 6 ohms, and we want to reduce it. The connection should be in parallel, because in parallel we have a resistance less than the resistor in the circuit. So I have here R5. Now R5 with R3 in parallel. To get R4, then R4 equals 1 over R3 plus 1 over R5 inverse. Substitute R4 is 1.5, 1 over R3 it is 6, plus 1 over R5 it is unknown, inverse. Do the calculation to find R5. We will find that R5 it is 2 ohms. You can solve for R5, and this R4 equals R3, R5, R3 plus R5, as you wish. So, to make the bridge balanced, connect a resistor with resistance two ohms with R3 in parallel. Now, the question needs to know how much is the current through the cell at equilibrium. To solve this, we have two currents here in this circuit, one through through R2 and Rx, which is I1, the other through R1 to R4, which is I2. Notice that there is the current in RO is 0. So we can assume that R2 with Rx in series and R1 with R4, not R3, because R3 will not satisfy the equilibrium condition. R1 plus R4 are in series. The result from R2 Rx is in parallel with the result of R1 and R4. So we can find the equilibrium, the equivalent resistance by this way. But it's more easy to find the current through the cell, since I1 will meet I2 at D, and they here will form I, which is I1 plus I2. How can we find I1 plus I2? Since there is no resistance between A and the battery, and there is no resistance as well between D and the battery, so the potential difference between A and D, it is the same as the battery. So delta V AB equals 14, and this will solve the problem. Delta V, now delta V AB equals VEMF, which is 14. Now for I1, we have delta V AB over the resistance between A and D through the point B. So the resistance from A to B to D. It is 14 divided by R2 plus Rx. 14 over R2 2, Rx 3. 14 over 5, it is 2.8. For I2, it is delta VAB over the resistance from A to D but through C, the other branch. From A to D through C. We have two resistors. They are R1 and R4. Again, it is not R3, R4. So delta V AB over R1 plus R4. Delta V 14. R1 it is 1. R4 it is 1.5. So the answer is now consider the given circuits and find the current in all branches. In what direction does the current flows between F and C? We cannot solve it by simplifying the circuit since there are two power supplies in two different branches. So we cannot easily simplify it. So we'll go with the Kirchhoff rules. First of all, we need to find our currents and assign it on the circuit. The question assigned them for us. And we have two joints or two junctions at B and C. So we can apply Kirchhoff junction rule once. At C, Kirchhoff junction rule yields to sigma I in equals sigma I out. The current I1 is going into C and I2 is going into C, but I3 out. So we put here I1 plus I2 equals I3, which leaves us with I1 plus I2 minus I3 equals 0. This is our first equation. Now apply Kirchhoff loop rule 2 times in the upper rule and in the lower rule. Here I will take it as counterclockwise and here clockwise. You can take any direction you want since the questions doesn't suggest anything. Now on the upper one, I will start from B, going to C, then F, then E, going back to B. I will have sigma IR equals sigma VM. If you go from now, first of all, find the currents with the resistance. I have a current here in this branch, I1 into 6 ohm, and in the same direction that I am following from B to C. So it is a positive. So I1 multiplied by 6, it is positive, plus. Now if you go up from C to F, there is a current, but there is no resistance, so ignore it. From F to E, we have a current, but we don't have a resistance. But from E to P, we have a resistance. What is the current here? It is I2. I2 is going here. It's come from F, from E, from B. So Here I2 going up to E, then going to F, and going down to C. This branch has only one current, which is I2. Now I2, if I am going from C to F to E to B, it is against me, opposites to me. So I must give it a minus sign, I2, and its resistance is 4. This is the resistance for I2. I'm going back to B, then equals. Now let us find the batteries in my way. From B to C, I have one battery, and in the same direction that I am following. So it is 10 with a positive, plus. From C to F, there is no battery, but from F to E, I have a battery, and it is in the same direction that I'm following. So it is 14. I'm going back to B. That's it. It is for the upper circuit. Now 6I1 minus 4I2 equals 24. This is the second equation. The third equation will come from the second loop. On the second loop, but I'm going counterclockwise. So I will start from A to B to C to D, going back to A. Sigma IR equals sigma EMF. Now let us find our currents. From C to D, it is I3. It will continue from D to A, here I3, and it will continue to B, here I3. At B, we have different current, which is I1, going from B to C. Now, starting from A to B, we have a current I3, but with no resistance, so ignore this step. From B to C, here, we have a current I1 in the same direction that I am going to with, and in 6 ohms times 6 plus, so 6I1 plus. From C to D, I have I3 with no resistance, but from D to A, I have a current I3 with the resistance 2, and in the same direction of analyzing, so 2I3 with a positive sign. Now I can look for the batteries. From A to B, no battery. From B to C, there is a battery, 10 volts, and it is in the same direction of the analyzing, so it is positive 10. From C to D, no battery. From B to D to A, no battery, so we are finished. This is the third equation. Now arrange these three equations to find some kind of determinant. I1 plus I2 minus I3 equals 0. This is the first one. The second one, 6I1 minus 4I2 equals 24. The third one, 6I1 plus 2I3 equals 10. Now the coefficients for I1 and I2 and I3 and the answer as well. From the first one, I1 has a coefficient of 1 and I2 also 1, but I3 minus 1, and the answer of the equation is 0. From equation number 2, for I1 I have 6 and I have minus 4 for I2, and there is no I3, so I put as 0, and the answer is 24. This is the answer. The third one, for I1 I have 6 For I2, I don't have I2, so it's 0. For I3, I have 2, and the answer is 10. Now go to your calculator, mode 5, 2 to find our currents. And the answers are I1 equals I2, I3. Stop the video and find the answer. Practice your calculator. For I1, I have 2. For I2, I have -3. For I3, I have -1. Means that I3 should be in the opposite direction and I2 should be in the opposite direction. So I3 should be from D to C and I2 should be from C to F. This takes us for the second question. In what direction does the current flows between F and C? From F and C, it is from F to C, but as we find here, it is -3, so it should be inverted from C to F. The current I2 is from C to F. Now for question number 5, same goal. Consider the given circuit in which I2 equals 4 milliampere and find epsilon 3. What is the direction of the current flow through epsilon 3? Find all delta VAF, delta VDB, F, and from C to F. It is not a classical question. You need to think here. Put the unknowns in the circuit. I2 is 4 milliampere. Here I2 it is 4 milliampere. Now you don't know I1 or I3. And you need epsilon 3. This is unknown. Pause the video and try to think how to get over this problem. Okay. If you take the first loop here to the left, we can find I1. It is only with one unknown, which is I1. It's easy as this. So Kirchhoff loop rule on A, B, C, F, A clockwise direction. Sigma BMF minus sigma IR equals 0, or sigma VMF equals sigma IR. Now check for the batteries first. From A to B, we have epsilon 1 in the same direction of analyzing, so it is positive. From B to C, there is no battery. From C to F, we have a battery, which is epsilon 2, but it is against us because we are going from C to F and the direction of the electromotive force is up from F to C. So it is minus epsilon. Now from F to A, there is no battery. So we are finished with the power supplies. Now for the right side of the equation, I times R. The current from A to B, it is the same from B to C, which is I1. The current here is I1. And it is the same from F to E to A. This is I1 again. Why? Because from junction to junction, without any other junctions, we have only one branch with one current. Okay. Now we can apply our equation. From A to B, we have I1 with no resistance, so ignore this step. From B to C, we have I1 but with no resistance, so ignore it. Now from C to F, we have a current I2, and I'm going from C to F, and the current from F to C. I2 is from F to C. It's against me, so I will put a minus sign, I2, with its resistance, which is R2. Plus, now from F to A, we have a current I1, and it is in the same direction that I'm following, so it is positive, I1 times R1. I1 times R1. Now substitute epsilon 1 is 24 minus epsilon 2 60 equals minus I2 4 milliamperes, so 4 times 10 to the minus 3 times R2, which is 3 kilo ohm, 3 times 10 to the 3 kilo ohm, and the current milliampere. Milliampere 10 to the minus 3, kilo 10 to the 3, plus I1, it is unknown, times R1, which is 2 kilo ohm, so 2 times 10 to the 3. Now solve this equation. 24 minus 60, it is minus 36. 10 to the power minus 3 with 10 to the 3, 1. 4 times 3, it is 12, minus 12. Plus 2 times 10 to the 3, I1. And here we have I1 equals 24 over 2, which is 12 milliampere with a minus sign. So it is in the opposite direction suggested by the diagram. Now try to find I3 because I have I2 and I1. Apply Kirchhoff junction rule at C. I1 plus I2, they are going into the joint or into the junction, but I3 is going out from the same junction. So Kirchhoff junction rule at C, sigma in equals sigma I out. I1 plus I2, they are in. I3, it is the out. So I will find I3. I1 is 4 milliampere plus I2, it is minus 12 milliampere. I use the magnitude with the direction I am getting from the equation equals I3. Now I3 equals minus 8 milliampere. Again, I3, it is in the opposite direction suggested by the diagram. So here we need to find epsilon 3. Now I am in the first branch or first paragraph of the question. Find epsilon 3. Here I need to apply Kirchhoff loop rule on the second loop from F to C to D to E and again to F in clockwise direction, on a clockwise direction, yes. Kirchhoff junction rule on FCDEF sigma BMF equals sigma I times R. First of all, epsilon 2 with me, epsilon 3 with me, so they both are positive. So epsilon 2 plus epsilon 3. For the currents, when I'm going from F to C, I have a current of I2 and it is with me because I'm going from F to C, and the current also from F to C. It's through 3 kilo ohm, and from C to D the current is I3. Again, it is with me, so it is positive, and it is going through R3. And if you follow to finish your loop, there is no other potential drop. So here we write I2R2 plus I3R3. I2R2 plus I3R3. Epsilon 2 it is 60 plus epsilon 3 it is unknown. I2 4 milliampere, so 4 to 10 to the minus 3. R2 I think it's 3 kilo ohm, so 3 times 10 to the 3 plus I3, I have it here with its sign, minus 8 milliampere times R3, it is 4 kilo ohm. 4 kilo ohm. 60 plus epsilon 3 equals 4 times 3, 12, minus 8 times 4, minus 32. Epsilon 0 equals 12 minus 32 minus 60, and the answer is minus 80. Again, the battery epsilon 3 should be inverted. Should be, the graph, it is drawn the negative up and the positive down. This is epsilon 3 in the graph. But since the answer is negative 80, it should be inverted. This is the real position for it. Now for part B, we need to find the direction of the current flowing through epsilon 3. What is the direction of the current flowing through epsilon 3? Through epsilon 3, the current is I3. It is indicated in the graph from C to D to E, so it's through epsilon 3 from D to E. But we have it with a minus sign in the calculations here, minus 8. So it should be inverted. It is not like in the diagram. It should be inverted. So it is from E to D. So the current I3 through epsilon 3 should be from E to F, up E to D, sorry, from E to D. Thank you. See you in the next part.
I hope that this video has enriched you more. In the description box below, there are links to both a PDF document for answers and the other videos in this series. This is the end of part 6. See you in part 7. Salam.